Visualization according to statisticians, an interview study on the role of visualization for inferential statistics. This was, as the title suggests, an interview study. We sought out and spoke to professional statisticians. We were interested in several questions, but in general, how is it that, or how do professional statisticians use statistics that are visual? How do they use visual statistics? How do they use visualizations? How do they perceive data visualization? For more formally, question 1, what tacit knowledge do expert analysts bring to statistical testing, which, embedded, would make tools most useful to novice analysts? Second, what design features make tools more likely to earn the statistical community's acceptance? And the sub-question of that, can outputs from a visual tool ever earn credibility within the expert statistical community? These were our participants. We spoke to 18 professional statisticians with an average of just about 20 years of experience each. They came from academia, they came from government, they came from private industry. Their educational experiences varied. 10 had a PhD, 8 had founded their career upon a master's degree. They were biostatisticians, professors, data scientists, statisticians, a variety of titles, a variety of degree titles. Some had teaching experience, some didn't. Demographically, they skewed older, of course, given the requirement for a long working experience. But even here, there was a good deal of variation. We spoke to 7 male participants, 11 female. There were, and this was the instrument we used. This was a semi-structured interview in essentially 3 parts. Now, the first part was a discussion, an open discussion of their analytic process, and not incidentally, how they use visualization, if they use visualization, within that process. So we presented them with the idea of being either given a data set or given a data task. How do you go from that to publication? And we used probing questions along the way to see whether they were using visualization for any of those steps. We found that there was broad agreement across participants in what the steps were. It's not that surprising. There's pre-collection phases, data collection and cleaning, exploratory analysis, confirmatory analysis, and then communicating out of findings. So that was the discussion of the analytic process. Now, during that discussion, we were collecting texts, any thoughts that they had, which could tell us something about their mindset, about how they viewed visualization, or more practically, what sorts of tools they used. We recorded those for later coding. The second part was graphic elicitation. This is where we attempted to elicit how statisticians actually think about an inferential statistical test. And we did this by asking them to actually draw what an inferential statistical test looks like to them inside their head. They were quite willing to do this. We received 9 participants drew some version of overlapping data distributions. There were 5 participants who drew a single distribution, the distribution of the test statistic itself. And then there were 3 participants who said, well, we actually don't think of statistical tests in visual terms. We think of them as the equations. So there was variation, but in the main, most professional statisticians with long experience think of inferential statistical testings in visual terms. The third section was the reactions to what we refer to as the straw men graphics. Now, straw men, an idea set up to be knocked down. We presented the statisticians with 3 different versions of a visual statistical test, or a visual representation of a statistical test. And we presented these to get their reactions and to see what kind of to see what their reactions were and to try to elicit their thoughts on these ideas. The first was overlapping data distributions. And what you see here are a pair of data samples, one in orange, one in blue. The mean of each data sample is indicated by the vertical line dropping down to the base. And then there's this set of gray lines near the top with an arrow separating them. Now, what that gray line shows is the amount of separation required for those two samples to be statistically significantly different at the highlighted level, in this case 1 in 1,000. So the gray lines indicate how much space, how much separation in the samples you would need to be statistically significantly different at the p-value equivalent of 0.001. And you can see that there isn't that much separation, so that these two samples are not statistically different at that level. The second of the strawman graphics was the distribution, or a version of the distribution of the sample statistic, derived through a sort of bootstrapping process. Here, the blue arrows on the side indicate how far out on that distribution you would need to go to be statistically significant at the different p-values. The third strawman was simply overlapping confidence intervals. Incidentally, what you're looking at are 95% confidence intervals, and the blue and the orange samples are different, statistically speaking, at the p-value equal to 0.05. So that's actually a statistically significant difference, though obviously that's very difficult to judge by eye. As I said, during the interviews, we were constantly collecting comments as texts, anything that would indicate the mindset, what tools they were using, or the tasks that they used to approach. And these we coded at different levels. There were the initial summary codes, then primary codes. These codes were grouped thematically, and then into 6 broad themes. Now, as for the tools that statisticians use, the first thing we found out is every single one of the statisticians that we spoke to uses visualization as a regular part of their work, just workaday work. They're using visualization all the time. And they are using different types of visualizations. Some are broad use visualizations, some are very narrow. The narrow use visualizations were particularly interesting because they're really moving towards being a visual statistical test. They're single purpose visualizations meant to test a single comparison. They also, you'll notice that those who saw equations when asked about statistical testing were among the most prolific users of visualization in other realms. Moreover, when we looked at the coding, the thematic coding, we discovered that the most common comment from these analysts on their thoughts about visualization were that visualization simply is analysis. It's not metaphor for analysis. It simply is analysis. They use visualization as analysis. Moreover, when we talked about epistemic warrants, we discovered that for 5, they felt that visualization was actually a stronger epistemic warrant than equation-based statistics, than math. They said some version of the comment, yeah, it's great to get a positive statistical test, but when I see it, then I can really believe it. So, in answer to the question, can outputs from a visual tool ever earn credibility within the expert statistical community? I think we have evidence that the answer is yes. So this was a wide-ranging study. There were lots of texts. We talked to the statisticians about a lot of subjects. Some key observations that came out of it. First, and this is probably the most important. Statisticians distrust any single approach to analysis. I said that it's possible that statisticians will trust visualization. Well, there were nearly as many people who said that visualization is great, but I really believe it when I see the math. In fact, there was one participant who said both things at different parts of the interview, because it turns out that it's not that statisticians trust visualization but distrust equation-based, or trust equation-based or distrust visualization. It's that statisticians appear not to trust any single, they don't seem to trust any single approach to their analyses. What they want to see are multiple lines of evidence all pointing in the same direction. Only when they can see it in a visualization, see it in the math, see it in a table, when all of these things line up, then they'll start to feel some degree of confidence in making a statement about what their data are actually saying. Second, statisticians express a preference for effect sizes over p-values. This may relate to the replicability crisis. And finally, statisticians misread confidence intervals. We are not the first people to find this. Other authors have commented on the robust misinterpretation of confidence intervals. But this is one more way that we were able to confirm this. Thank you very much for listening, and I look forward to seeing you at the conference.